Hey, welcome to our explainer. Today we're going to talk about a silent, humble little box that makes our entire electrical world possible. It's an invention that's so crucial, it's literally hiding in plain sight. I mean, have you ever really thought about it? On one end, you've got this gigantic power plant just churning out millions of volts of raw energy. And on the other end, there's your delicate smartphone, which needs just a tiny controlled sip of that power. So how do you bridge that massive, massive gap? Well, the solution isn't some high-tech, fancy new microchip or a complex computer. Nope, it's a brilliant and honestly remarkably simple device that was invented back when steam power was still the king. And this thing is the absolute bedrock of our global electrical grid. So let's go ahead and formally meet the hero of our story, the transformer. At its heart, a transformer is basically a voltage controller. Just think of voltage as electrical pressure, right? A transformer can take the super high-pressure electricity from the power grid and reduce it to a safe, low pressure for your home. Or it can do the exact opposite. It's the ultimate electrical middleman.
And what's kind of wild is that the science behind it is surprisingly old. We gotta go all the way back to 1831, when the genius Michael Faraday figured out this fundamental link between electricity and magnetism. He laid the groundwork for technology that would quite literally power the entire world.
You know, what's so remarkable is just how simple the design is. You don't need any gears or motors or anything complicated. All it takes are three basic parts: an iron core and two separate coils of copper wire. That's it. That is all you need to perform this incredible electrical magic trick. Okay, so how does it work with zero moving parts? Well, the answer lies in this really beautiful bit of physics called electromagnetic induction. This right here is the key. Faraday discovered that a changing magnetic field can actually create an electrical current in a wire that's just sitting nearby. It's not a physical connection. It's an invisible force field that's doing all the heavy lifting. Let's walk through it step by step. First, alternating current, or AC, flows into that first primary coil. Now, because AC is always flipping its direction, it generates this pulsing, changing magnetic field. The iron core acts like a highway, basically, guiding that magnetic field over to the second coil. And when that moving magnetic field washes over that second coil, boom, a brand new electrical current is created out of thin air. So here's the crucial part, the thing you have to remember. The electricity is transferred wirelessly from one coil to the other through a magnetic field. It's called mutual induction, and it's what makes the transformer so unbelievably elegant and efficient. There's no friction, no moving parts to wear out. It just works. All right, so now that we know how it works, let's look at what it does. This whole principle of induction lets transformers do two opposite but equally vital jobs. The secret is just brilliantly simple. It's all about the ratio of turns in those wire coils. If you want to increase the voltage, or step it up, the secondary coil just needs to have more turns than the primary one. That's a step-up transformer, and we use those to send power over really long distances. Now, to decrease the voltage for, say, your neighborhood, the secondary coil has fewer turns. And that, you guessed it, is a step-down transformer. But, there's a trade-off. The total amount of power stays the same. So when you step up the voltage, the current has to go down, and when you step the voltage down, the current goes up. And this is so important because sending electricity at super high voltage and low current across the country is way more efficient. You lose a lot less energy as heat. So let's see how all of this comes together to build the entire system. We can actually follow the journey of electricity from the power plant all the way to the outlet in your wall. It all kicks off at the generation station. Electricity is made, and then right away, it meets a massive step-up transformer. This thing boosts the voltage up to incredibly high levels, getting it ready for its long-distance trip across the country on those big, high-tension power lines. So after traveling for hundreds of miles, that high-voltage electricity arrives at a regional substation. And here, a big step-down transformer does the first major voltage drop, lowering it to a much more manageable level so it can be distributed throughout a city or a town. And for the final step, you've seen these. That familiar green or gray box on a utility pole in your neighborhood, that's a distribution transformer. It takes that power and steps it down one last time to the safe, standard voltage that you use to power literally everything in your home. Of course, it's not just one type of transformer doing all the work. It's a whole team. You've got these huge power transformers at the source, smaller distribution transformers near our homes, and even specialized measurement and protection transformers that kind of act like the senses and security guards of the whole electrical grid.
So after seeing this whole journey, let's just step back for a second and ask the big question, why is this one single device so important?
And the answer is pretty simple. Everything we know about modern electricity depends on it. Without the ability to efficiently step voltage up for a long trip and then step it down for safe use, our grid just couldn't exist. We'd need a power plant on every single street corner. The transformer is the essential, unsung linchpin of our entire connected world.
It's really incredible when you think about it. This elegant principle discovered almost 200 years ago is still doing all the heavy lifting for our civilization. It really makes you wonder, as our energy needs keep changing, what simple, brilliant invention is going to come along to define the grid of the future? Thanks for joining us.